Okay, I just wanted to give a little background information about where these two equations come from, these two formulas. So on the off chance that you forget these formulas, you could go the long way and get to the answer, but also so that you understand that somebody didn't just make these up. Okay, when we're doing the product of two complex numbers, we said that the formula was the product of the two R values, cosine of the sum of the two angles plus I times sine of the sum of the two angles. When we did the quotient, we said that we did the quotient of the two R values, and then for our cosine, we did the difference of the angles, and for sine, we did the difference of the angles. So what I'm going to do here in this video is just quickly show you why these actually work and what you would have to do if you forgot these formulas. Okay, so I'm going to use the exact same numbers, and I'm going to do it with numbers instead of with variables because I think it will be easier for you to follow. So same two complex numbers that I had on the previous page. If I am going to multiply them and I don't know the formula, I would first write them out as multiplication. Now, since multiplication can be done in any order, I can group the 5 and the 4 together and then group the two binomials there. And then what I did, so I've got these two grouped as the 5 times 4, and then I'm multiplying these two binomials, and I'm going to have to FOIL that. So when I FOILed that, I had my cosine 110 times my cosine 70. I have my I cosine times my 110 times my sine of 70, and I did rearrange the order of that multiplication, so I have these two. Then I have the I sine 110 times the cosine 70, and then I have the I squared sine 110 and the sine 70. Now you can see that I've underlined these two and I've kind of squiggled this one. So I'm going to rearrange and I'm going to do a little grouping in the next step. And again, I've kept this as the 5 and the 4 so you can see those separate. So if I group these together and I remember that I squared is a -1, then it can be written like this. And if I think about my sine and cosine, my sum and difference of angles formulas, what I see here is I have my cosine, cosine, sine, sine. Okay, so remember sine, cosine, cosine, sine, and then cosine, cosine, sine, sine. So this must be a cosine formula, and with cosine our signs were different, so it became cosine 110 plus 70. So recognizing that this is a cosine sum formula, I could rewrite this in a simpler fashion. I'll come back to this notation in a moment. On this one, they both have an I, so I factored out the I. And again, recognizing this as a sine sum of angles formula, sine, cosine, cosine, sine, I did do, just grouping that together here. And then it gets rewritten as my sine 110 plus 70. So then if I think of these angles instead of as the 110 and the 70 as a theta and a theta 1, I can write this in that general form that I had on the previous page. Product of the two R values, cosine sum of the angles, I sine sum of the angles. So obviously if you know the formula, it's going to be much easier because you can skip all of this middle stuff and then just jump and do the evaluating and the simplifying that we saw on the previous page. Okay, on the bottom part, it's going to be the exact same idea, except for we're going to be working with our division, our quotient. So what you would actually start with is what we have here, dividing our two complex numbers. And then the first thing that I'm going to notice is I'm going to rationalize. So I'm going to multiply the top and the bottom by its conjugate. Remember, I need the conjugate of the denominator, so I just flip that sign. Then I'm going to have to start FOILing. So again, in the numerator, I have FOILed out these two complex numbers. The cosine 110 and the sine 70 gets me the first piece. Then my negative, my I cosine 110 and my sine 70 gets me this. My next one gets the two inner pieces. The last one minus my I squared and my sine 110 sine 70. You'll notice in the denominator, I did not go ahead and write out all of the complete foiling there because I know that if these are conjugates that the middle terms drop out. So I get cosine squared 70, and then I have a negative I squared, which of course switches to a plus, and then sine squared 70. This of course is going to simplify to a 1 because it is my Pythagorean identity. So now I'm really back to a similar process to what I did on the previous one. Just grouping. I group these two ends, I get rid of the I squared, so it's going to become a plus. Now I have my cosine, I need to recognize this as a cosine sum of angles, so cosine, cosine, sine, sine, and plus we know the sign is going to be opposite, so that's why it becomes a minus. So this part becomes cosine 110 minus 70. Once again, I factored out my I. This is my sine difference of angles. So sines are the same, 110 minus 70. Again, thinking of this as a theta 1 and a theta 2, I can write it in its general form. So if you forget the formulas that I have on the previous page, you could go through this much longer process and still get to your final answer.